What does the universe smell like? You may have heard that space smells like gunpowder, alcohol, raspberries, or rotten eggs. An interesting bouquet. But is it true? What does space actually smell like? And does it smell at all?
On the one hand, the question may seem strange for now, but on the other hand, we interact with the world, we perceive it through the main senses. Usually we talk about 5.
In everyday terms, we mostly rely on vision. We look through telescopes and at astronomical photographs. Occasionally we get to listen to space, and not in sonified form, where some data is converted into sound, as done here, but directly, when microphones are installed on spacecraft like on the Perseverance rover, thanks to which we heard Mars.
But why not bring in the sense of smell here? When answering the question of what space smells like or how it smells, we should also clarify where exactly in space. Space is a broad concept, and today we're going to talk about everything.
About near-Earth space, the Moon, the planets of the solar system, interstellar space, and even the smell of the Big Bang, and whether we could actually perceive all of this. And also about what those who, in a sense, have managed to actually smell space have to say.
I'm Andrei, and this is Cosmos Elementary.
Is it at least possible to get some idea of what the universe smelled like shortly after the Big Bang? To answer this question and whether we could perceive anything in a particular part of space, we first need, to make a couple of assumptions.
Well, for example, that we wouldn't die there instantly, or within a minute or two, depending on where we are.
We also need to at least briefly talk about how the sense of smell works. Naturally, there are many nuances and even some aspects that haven't been fully studied, but for now, a brief overview will be enough.
We possess the ability of chemoreception, and in us and in mammals in general, it includes the ability to perceive taste and smell.
Obviously, to perceive the smell of a substance, it must reach, our nose in a gaseous state. We have olfactory receptors in our nose, and the molecules of a substance that reach our nose interact with these receptors. Moreover, in the universe, and even just here on Earth, there are more odors than there are receptors, and each molecule can stimulate a specific combination of receptors. And when a substance interacts with the olfactory receptors, a signal is sent to the brain. These signals also depend on the properties of the molecules, their shapes, their sizes. Then the brain interprets these signals and we perceive a specific smell. Often a familiar to us smell is not the result of just a single substance interacting. For example, the smell of coffee comes from a combination of more than 200 chemical components, and none of them on their own actually smell like coffee. But, of course, there are also simple substances that can have a very distinctive smell.
Here, we can already conclude that our sense of smell is subjective. I mean that since the smell we perceive is only our brain's interpretation of the signals it receives, we cannot be sure that we all perceive the same smell.
This is reminiscent of the situation with color. After all, colors are also the way our brain interprets signals from the eyes, which have registered light of a certain wavelength. And perhaps we all call the bottom traffic light green, but the image different people see is not the same. We can be sure that we see the same green because we can't get inside each other's heads. Perhaps something similar is true with smells as well. Moreover, the same smell can often be liked by one person and disliked by another.
After having COVID, many things, and not only food, started to smell to me like something resembling rotten fried onions, and some products like some kind of household chemicals. And the taste too, by the way, which isn't surprising since the sense of taste strongly depends on smell. Luckily, over time it almost went away, but it lasted for a very long time.
Another very important point. When I was talking about the interaction of a substance with the receptors, I didn't mention atoms for a reason. I specifically talked about molecules. Receptors respond to molecules, so a substance in its pure atomic form, for the most part, won't have a smell.
For example, some simple molecules too. For example, oxygen, O2, under normal conditions, it's a gas without any smell.
Actually, it would be very inconvenient if it had a smell, considering that we, well, kind of breathe it in. But if we add just one atom, we get ozone, O3, which already has a very distinctive smell. That very smell of a thunderstorm, or in higher concentrations, it resembles the smell of some cleaning agent.
You might be puzzled by the fact that some chemical elements in their atomic form have no smell. And surely many will recall
Sulfur, for example. Since sulfur also seems to have a very distinctive smell. The thing is, everything we call the smell of sulfur is actually the smell of sulfur compounds, that is, different molecules. Pure sulfur itself has no smell. And there's one more important point, specifically for space and for our topic today. Our ability to perceive a smell depends on the concentration of a given substance. If it is below a certain threshold, we won't sense anything. Moreover, this threshold is different for different substances. So if we want to understand what a smell might be like, say, on Jupiter or on a comet or somewhere in a nebula, and whether we could actually perceive it, we need to know which substances are there and in what concentrations. And of course, assume that these cosmic locations wouldn't instantly kill us. Speaking of cosmic smells, let's start from the very beginning. The beginning of the universe. Let's suppose we could travel back to the very start of the universe. Well, not the very first moments, which our current theories can't even describe, but a bit later, when the universe had at least expanded somewhat.
So we went there and immediately got burned in the scorching plasma.
For now, let's not worry about a minor detail like surviving the incredibly hot conditions of the early universe, and let's suppose we have some kind of protective bubble. Now, if we just take a substance from the universe at that time, would we be able to smell anything? Well, we've already established that what our sense of smell interprets as odors is the interaction with specific molecules.
Back then, not to mention molecules, there weren't even fully formed atoms yet.
Quarks and electrons appeared millions of a second after the beginning of the universe. Then the universe had cooled enough for quarks to form protons and neutrons. And during the first minutes of the universe's existence, atomic nuclei appeared, mostly hydrogen and helium.
And we won't see the first neutral atoms for hundreds of thousands of years yet.
On one hand, wherever we were in the universe at the time, there would have been plenty of matter everywhere. The density was high. The whole universe was a dense soup of hot plasma. However, the matter was in such a form that, even ignoring the extreme conditions, our sense of smell would most likely not be able to interpret it as an odor. First neutral atoms formed around 380,000 years after the beginning of the universe, when it expanded and cooled enough. At that time, matter in the universe consisted almost entirely of hydrogen and helium, with a little bit of lithium and a couple of isotopic variants. None of this would have had a smell in the usual sense for us. We would need molecules, and more interesting ones at that.
It should be noted that the first molecule in the universe appeared roughly at the same time as the first atoms.
Today it is believed that the first molecule was helium hydride, or the helium hydride ion. It preceded molecular hydrogen, but even here it's safe to say that there was no smell to speak of. The early universe was far too chemically primitive. Take the ozone we mentioned earlier. It's generally associated with planetary atmospheres, but it can also exist in interstellar space. For a molecule of 3 oxygen atoms to form, well, it's obvious that oxygen is needed, and oxygen is produced in the cores of stars. Therefore, the first stars had to form, and then some had to die in order to eject the heavier elements they produced into the surrounding space. We owe the chemical diversity in the universe mainly to stars and the processes associated with them. The first stars appeared much later, approximately 100 million years after the universe began expanding, and once stars had ignited and then started to die, heavier elements began to form. and the first molecules, including organic ones, could appear. Only then we can start talking about the emergence of the first smells, at least those that we humans could in principle perceive. So let's move forward to a more modern universe. Today, using telescopes and spectroscopic observations, astronomers are able to study the chemical composition of various cosmic regions and objects. And they have long been finding a wide variety of molecules, even in interstellar space, and some of them are quite complex. Among these substances are ones that for us are associated with very specific smells. One of the most famous examples is the smell of raspberries, which I mentioned at the very beginning. And this smell was found not just anywhere, but in the center of our galaxy. More specifically, in the Sagittarius B2 molecular cloud. There, scientists have detected the presence of a substance called ethyl formate. It gives off the characteristic smell of raspberries, and also of rum. Speaking of rum, the same cloud contains plenty of alcohol as well, more precisely vinyl alcohol and of course ethyl alcohol, which also has a very distinctive smell.
The raw smells in space not as pleasant as raspberries.
Take a look at this beautiful nebula. Do you know what it's called? The Egg Nebula, or the Sulfur Nebula, and it's often nicknamed Rotten Egg Nebula. A large number of sulfur compounds have been found there, such as sulfur oxide, which smells like a burning match, and of course hydrogen sulfide, whose smell is unmistakable, hence the name the Rotten Egg Nebula. But okay, we found places in space that contain substances with smells we can recognize. In news articles and popular science pieces about these nebulae, they often say things like, "It smells like raspberries there." But if we actually ended up there, took off our spacesuit helmet, within a few dozen seconds we'd pass out, and within a couple of minutes we'd die from oxygen deprivation in the brain. Again, let's suppose that there were no problems with the lack of air or anything like that. In such a hypothetical scenario, would we actually be able to smell anything there? Well, that depends on the concentration of those substances.
As I already mentioned, for different substances, the threshold at which we perceive a smell varies.
For example, on Earth, one substance we can detect even at very low concentrations is geosmin. It's produced by microorganisms and gives soil its characteristic smell. For us to notice it, as little as 5 parts per trillion in the air may be enough. But that's in air. Applying the same logic to interstellar space is difficult. After all, interstellar space is almost a vacuum. Yes, there is matter there, but very little of it. There may be just 1 atom per cubic centimeter or even less. Even in denser clouds, like the ones we've been talking about, where the density is much higher, a few hundred particles per cubic centimeter, and that's still extremely little.
For comparison, in the air, there are roughly 2.7 times 10 to the power of 19 particles per cubic centimeter. That is 27 million trillion particles.
So even if we found ourselves there and somehow avoided the problem of breathing, we would most likely still not smell anything. No raspberries, no alcohol, no rotten eggs. And when people say that space smells like raspberries, it's more of a figure of speech. Yes, that substance is there, but in any given volume of space, there is far too little of it.
But still, it's not like that everywhere. After all, we also have planets.
Up to this point, our problem has been the low density of matter. But where else could we find a more or less high density of gaseous matter beyond Earth? Of course, in the atmospheres of other planets or moons. Naturally, most of the information we have on this comes from within our solar system. Judging by Earth, it's certainly strange to ask, what does a planet smell like, given the incredible variety of smells here? But we don't have such detailed information about other planets as we do about Earth. So here we have to think in a simplified way. Mercury has virtually no atmosphere, so there is really nothing to talk about there. Venus, on the other hand, as we know, has a dense atmosphere. Let's take a look at its main components. Out of all the components here, only one has a pronounced smell, the sulfur oxide we mentioned today, which smells like a just struck match. By the way, the chart shows its concentration, which means that considering we're talking about a dense atmosphere, we can even estimate whether we would be able to smell it there. That is, assuming we weren't roasted by the temperature of over 460 degrees Celsius or about 860 Fahrenheit, and that we actually had something to breathe. According to NASA's website, its concentration is 150 ppm, or parts per million. And our sense of smell can detect a fairly strong odor starting at just 0.67 parts per million. So, based on the overall data, on average, Venus would smell like a lit match. At least that's one of the most pronounced odors. So, let's move on to Mars. If we look at the main components of its atmosphere, there's also only one gas with a distinct smell: nitric oxide. It has a sweet smell, and again, its concentration here is fairly high. Although in certain amounts, other substances with smell have also been detected there by instruments on the surface. These include various sulfur compounds, different acids, and compounds containing magnesium, iron, and chlorine. It's hard to say exactly how this mixture would smell in any specific location. Some might also recall a characteristic feature of Mars, the presence of a large amount of iron oxide, or simply rust, which also gives Mars its distinctive reddish hue. Wouldn't all that rust have a smell? The thing is, pure iron oxide itself actually has no odor. And we perceive a smell, for example, when we hold a rusty object in our hands and substances from the rust interact with the chemicals on our skin. Next, we have the gas giants, which don't have a solid surface in the usual sense. In Jupiter's atmosphere, ammonia is present in fairly large quantities at certain depths, and ammonia has a strong smell. We might recognize its smell from certain cleaning products. On Saturn too, most of the planet consists of odorless substances, but as on Jupiter, ammonia is present in certain quantities. By the way, speaking of Saturn, we can't forget its largest moon, Titan. It also, as we know, has a dense atmosphere with lakes and seas made of hydrocarbons. Interestingly, according to NASA and the data from Cassini-Huygens mission, they even recreated the smell of Titan, and it turned out that the odor on this unique moon could resemble gasoline. Next, the ice giants differ from Jupiter and Saturn. In the upper layers of Uranus's atmosphere, for example, hydrogen sulfide has been detected, a gas that's practically absent on the gas giants, so Uranus would smell like rotten eggs.
Of course, we could make another comparison here, like what Uranus might smell like. But I think you've already guessed.
On Neptune, hydrogen sulfide may also be present. Another stinky object in the solar system is Comet Churyumov-Gerasimenko. There, in addition to ammonia and hydrogen sulfide, formaldehyde was also detected, which doesn't exactly smell pleasant either. So, overall it's quite a little cocktail. But here we're just thinking about how a particular cosmic object might smell based on the fact that certain substances are present there.
But there are those who have already smelled space, and in a way we can smell it ourselves too. So here we have two main paths.
First of all, people have actually visited space and they've reported unexpected smells they experienced there.
Secondly, space, in a sense, sometimes comes to us.
In the form of meteorites, which, by the way, can have origins from the Moon and Mars as well. And we also have samples brought back by humans or spacecraft from certain celestial bodies.
The most accessible way to check if something of extraterrestrial origin has a smell is through meteorites. You don't need to fly into space for this, and it's not even always necessary to have access to scientific laboratories.
I have a fragment of an iron meteorite. By itself, it doesn't really have much of a smell. Some museums also have meteorites that aren't behind glass.
Of course, I'm by no means suggesting going to museums and sniffing meteorites, but you can quite easily buy meteorites or items made from meteoritic material as souvenirs.
Of course, meteorites vary. They're made of different materials, and that can affect their smell, if they have one at all. In 1969, a primitive carbonaceous chondrite fell in Australia. We know it as Murchison meteorite. It's one of the most well-studied meteorites in the world. It's interesting because dozens of amino acids were found in it. Additionally, it contained so-called pre-solar grains. I made a video about them a while ago. They're made of material that's older than our solar system. Dating has shown that it contains grains of stardust up to 7 billion years old, while our solar system is only 4.6 billion years old.
There are some quirks with the smells there too.
When people found it, after it fell, eyewitnesses noted that it had a noticeable smell. Interestingly, people described different odors. Some said it smelled like denatured alcohol and tar. Others said it smelled like wet hay.
Later, when scientists studied fragments of the meteorite in the lab, they described its smell as smoky, dusty, and acidic, something like what's left of a cigar and a vacuum cleaner dust bag. Another group of scientists said that during certain studies, their samples of this meteorite smelled like a sandwich with spoiled peanut butter.
And another meteorite, which also contained a lot of organic material, smelled like Brussels sprouts. We also have quite a few samples from the moon. Interestingly, these samples don't seem to have any noticeable smell here on Earth. Well, so does the moon have no smell at all? Well, not necessarily. Apollo mission astronauts reported that after walking on the moon, when they returned to the module and took off their helmet, they noticed a smell that hadn't been there before, and it resembled the smell of gunpowder. It's possible that this was the smell of lunar regolith, the dust that had settled on their spacesuits. But there's nothing particularly surprising here. There's plenty of material on the moon that could stick to a spacesuit. But perhaps the strangest thing is that astronauts notice smells after spacewalks. After all, they go out into almost a complete vacuum and spend some time there. Yet, astronauts reported experiencing different odors. Some describe a sweet, metallic smell, like hot metal, burnt meat, burnt cake, and almond cookies, or the smell of soldering metal. Others compare the smell after a spacewalk to ozone and also to the smell of walnuts and brake pads. Interestingly, NASA has even recreated these smells based on astronauts' descriptions, for example, to make training on Earth more realistic.
But where does this smell come from? We don't know for sure, but there are two main theories. Firstly, it could be due to oxidation.
While outside the ISS, there is almost a complete vacuum. The key word here is almost. The station is still within the upper layers of Earth's atmosphere. And although there's very little matter there, it's enough, for example, to gradually slow the station down, which is why its orbit has to be periodically boosted using engines. Without this, it would eventually fall. So, at the altitude of the ISS, molecular oxygen, O2, is broken down by the sun's ultraviolet radiation into atomic oxygen. Oxygen atoms can end up inside spacesuits, on the walls of the station's airlocks, and on other surfaces exposed to outer space. And when astronauts return to the station, this atomic oxygen combines with molecular oxygen to form ozone molecules, creating the characteristic smell.
But what about other smells? Here, dying stars could be to blame for everything.
In supernovae, substances such as polycyclic aromatic hydrocarbons, abbreviated as PAH, can form. They have various odors, and dying stars scatter them throughout the universe. They've also been detected multiple times within our solar system. So, they can be present in near-Earth space and end up on astronaut spacesuits during spacewalks. However, so far these are only hypotheses and they lack full scientific confirmation. In general, the idea that space can smell in a certain sense isn't obvious. But it's not just an interesting curiosity. It's also a way to better understand the various processes occurring in space, the properties of different celestial bodies, and the universe itself.
Thanks for watching. Links to all of the sources are, as always, down below in the description. If it's your first time on my channel, feel free to check out my other videos. I have plenty of them, and they don't get too many views. So if you enjoyed this one, leave a like, comment, and subscribe for more videos in the future.